Okay, so in this video, we're going to show how to solder all of the wiring components to the Malenki for Squeezy or for the Creatabots or for any other bot where the Malenki is just going to sit flat on the bottom of the chassis, meaning that we can put all the wiring components in to the top, like on the same side. So in our overthrow and slammer, because the Malenki sits almost vertical, we bring power in on the front and keeping the LEDs pointing slightly up. The other components go out the back. But for Squeezy, Creatabots, and most other bots that can let the Malenki just sit flat on the floor, it's better to put all the components in from the top side and making sure the LEDs still shine up, which will mean we'll be soldering onto the back. So what we're going to do is we'll start by doing all of the power. So power in from the battery connector and switch, and power out to the servo, which would also be to a brushless ESC. So because I want these wires to be more towards the center than the power wires, I'm going to put these in first, and red can go in either plus and brown or ground can go in either minus, but I tend to put these towards the bottom. And then with the power and ground from the battery and switch, we'll put those into the top two. So this is having these double solder rings is known as power distribution, and it makes a good, easy, clean solder joint to supply power, like I said, to your servo or to a brushless ESC. So what I've done is given them a little bit of a wave there so that the wires are going relatively straight in, and I've been able to get all the wires flat, red, and positive, black and brown and negative. And what this will let me do is I can grab all four of these with one of these Omnifixio clamps. Now, if you've watched any of my other soldering videos, you know I'm a huge fan of just using a big glob of fun tack or blue tack, which would mean when I have all those arranged the way I want them, I can just stick it on there and it holds them really well. But again, what I'm looking for is that my insulation is all the way up against the circuit board, and then I'm going to go for some nice clean solder joints, and you can see the black ones pulled away a little bit. It's one of those places where sometimes it's nice to have some needle nose, but I can just give that a little bit of encouragement to come through a little bit more, and then feel pretty good about that. But we can give it a little bit of a push. This is a little bit harder when I'm trying to make sure that the camera can see it too. But here we go. There's our, we'll go ahead and zoom in, the actual soldering. So you can see I have all the insulation's flush, and I'm noting how far above the back of the board each of those wires sits, and I want to make sure that they don't slide in when I go to solder them. So what I'm going to do is I'll clean the iron. If it's sat for more than a little bit, it's good to clean it, and then tin it just a smidge. I'm going to stick the iron into the ring to heat the ring, and then I'm going to feed the solder in to fill the entire solder ring with solder. You've heard me talk before about how much I love the hook tip, because I find that even easier to make sure that the heat is transferring to the ring itself, but those are more unusual, so I'm using just a straight pin tip to demonstrate this, because that comes in most kits. So I'm flowing in as I see it suck in, and I can just pull that out. And it covered all of the gold, so that's good. And same thing here, I'm gonna touch the ring with the iron, transferring heat to the ring. I flow in solder, see it suck in, and pull it out. And obviously these two can be shorted because those are electrically and thermally connected. And I'll move on to this one. So again, I'm heating the ring. I'm going to flow the solder in. As I see it wick the solder down, I'll feed a little bit more, and I can pull the iron. And for the last one, again, making sure that my iron is touching the ring. It's key that you're heating the ring so that it wicks the solder. Solder follows the heat, so you got to get the heat from the iron to the ring. Then you flow the solder in, and the solder wicks down where the heat is and fills that whole joint. So you can see that I've gotten the solder to come all the way through in these joints, meaning that those are good, strong joints. Now, the red and black, most of the wires we provide are silicone jacketed, so they're not going to heat, they're not going to melt or pull back at all. The servo wires are not silicone jacketed, so they may pull back a little bit, but that's still very, very little exposed wire. Often we do go ahead and we can trim these even a little bit more flush. That'll help it sit nicely. So there's power in and out of the Malenki. And then we'll go ahead and do our first motor connector. Now, I keep the red and black aligned. It's not really critical with these because it's so easy to reverse a channel in the Malenki configuration, but there's also no downside to it. So what I'm doing here is again, making sure that my wires, the insulation is going to be flush to the board. I'm going to clamp these 4 wires with the Omnifixio clamp, and I'm going to do it in such a way that I'll be able to see it nicely, and it'll keep the insulation up against the board. Often I'll just kind of nudge the board in a certain direction. It's with the Omnifixios, clamping them the only simple way to clamp them is at 90-degree angles to each other. So again, one of the advantages of the blue tack method is you just mash it in where you need it to be and it stays. But do that and then get this back to the center, and usually have something nearby to brace it up so that I can get the angle that I want. And I want to make sure that it's clear to the camera. How I do this. There we go. So again, I'll often make sure I have a nice arc on my solder. When I finish this, I'll of course wash my hands with cold water and soap immediately. Lots of people wear gloves, and that's not a bad idea either. Tin the iron just a bit, and then I'm going to touch the iron to the ring and then flow the solder in. I'm watching the solder as it flows fully into the ring, and then I can pull the iron out. Same thing here. I'll get the iron into the ring, flow the solder in, watch for it to wick all the way in, then pull it out. When I do that right, I get those perfect little volcano shapes where it's sticking up. And then we can check it. My insulation stayed down nice and close to the board. You can see the solder flowed all the way through. That is a very good mechanical and electrical connection. And it's important to remember that's what we're going for with these. It's not just to get the wire to mostly stick to the right place. It really is about having the lowest resistance connection that we can. And with these, it's good to also have the best mechanical connection that we can. So with the last motor connector, this is the right side, and the longer ones, it goes into the R. I'm again going to have those 4 wires pinched where I can grab them and do my best to get equal pressure on them. I'll set up another one of these to help support the Malenki. I think I want this higher this time to give you all the right view. And give you a slightly different view. There we go. And again, I'm gonna get my nice arc on, bump the camera. I'm gonna get my nice arc on my solder. Gonna tin the tip just a smidge. Get the iron into the ring to heat the ring. Flow in the solder. And then remove the iron. And then same thing with the top hole. Heating the ring, then flowing in the solder. When I see that it's taken all it can, I'll remove the iron. And again, we got good joints, insulation stayed low, solder went all the way through. That looks great. Clean my iron and put it away. And then there we go. That's everything except the signal to the servo. So that one's quite easy. Only takes a second. Now, I can use the Omnifixio correctly. If you grab it only in one way, it pivots really easy. But if you can get two of these clamps at angles to each other, then it holds it much more securely. So, as always, clean the tip, and then now these are solder pads. They do have holes in them, and those holes are vias. Those are not solder rings. So we see people trying to put the wire through those tiny holes. You don't need to do that. It doesn't hurt if you do that, but the holes are a via that means how to get somewhere. So the vias just take the electrical connection from the pad on the top to the pad on the bottom. So again, as a solder pad, you generally just heat the pad and you build a little solder pillow on it, and then we'll stick the wire to it. It's not about trying to put it through it. And what I found works best on these is I just grab some needle nose so I can control it really well and close. And then when I come in here, I will often heat both the pad and the wire. And I hold it till it freezes, and there we go. That is complete. And I'll always double check to make sure I don't have any shorts. So that didn't go short to the next pad. Those two aren't touching. Those two aren't touching. I have no shorts. My reds and my blacks are in the right place. That's also important. And there we go. So that is we'll zoom back out here. That's a fully soldered Malenki harness. Ready to go. Just plug in your battery, your motors, and your servo, and get to testing.